The numbers that we will use this term will come from the system we call the real numbers. The real numbers are any number you can find or place on a number line. There are numbers that exist outside of the number line, and you'll see those in future math courses. Because of the different ways that numbers are used, they've been broken down into smaller subcategories, because we will use certain real numbers in different situations. We will approach this from a building up perspective. We will start with the smallest set of real numbers, and then build up so we can eventually cover the entire number line. The smallest set of real numbers that we choose to work with is what we call the natural numbers. The natural numbers is the set that you first learn to work with as a child. The first thing you learn how to do is how to count. 1, 2, 3. Those numbers, 1, 2, 3, 4, and so on, forever building up, are what we call the natural numbers. All of the subsequent sets we use on the left side of this diagram will be built up by adding things into the set of natural numbers. So you first learn how to count 1, 2, 3, 4. The next thing that you learn as a child is there is another number, the number 0. When we add 0 to the set of natural numbers, that becomes the set of whole numbers. So the whole numbers are all the natural numbers with 0 added into the mix. The way this diagram is constructed is that the box containing the natural numbers sits within the box of the whole numbers. So every natural number is a whole number, but not every whole number is a natural number. But also because the natural number box is within the whole number box, I don't need to rewrite all of the natural numbers. After you learn how to count and have the natural numbers, and then introduce the idea that maybe you don't have something that particular day and you have your whole numbers, there's also the possibility that you have debt. When you bring in the positive and negative whole numbers, that is what we call the integers. The integers are all the whole numbers, all the natural numbers, but also they include the negative whole numbers and the negative natural numbers. -1, -2, -3, and so on. Again, every whole number and every natural number is an integer, but not every integer is a whole number or a natural number. The final set on the left side of our diagram is what we call the rational numbers. The set of rational numbers is built up of all the numbers from the number line that can be written as a fraction of two integers. Contained in the word rational is the word ratio, and a ratio is just a fraction. So an easy way to remember the rational numbers is that they are the things that are or could be fractions. So if you take a natural number, such as 2, 2 could be a fraction as 2 over 1. Take an integer, -3. -3 could be written as a fraction, -3 over 1. So it includes all of the previous things that we've had, even the number 0. 0 could be written as a fraction, 0 over 1. But then it also goes on to include things like 1/2, -7/4, and any other number that could be written as a fraction of integers, whole numbers, and natural numbers. The one restriction is you cannot have a denominator of 0. A fraction that has a denominator of 0 would not belong to the rational numbers. There is one other complication with the rational numbers. The rational numbers also include some decimals. Decimals that repeat are rational numbers. For example, 0.33333, where the 3 repeats, is the same thing as the fraction 1/3. And decimals that terminate or stop are also rational numbers. If you think of the decimal 0.1, that is the same thing as 1 over 10. So the complication with the rational numbers is they may be presented as a fraction, or they may be presented as an integer, or they may be presented as a decimal, and when they're decimals you have to recognize repeating decimals and terminating decimals are also fractions. The other category of real numbers that we work with are what we call the irrational numbers. If you look at the meaning of irrational, irrational means not rational. So if rational numbers are all the things that can be written as fractions, then irrational numbers are all the numbers on the number line that cannot be written as fractions of integers. The most common example that people are familiar with is pi. Pi is a number on the number line. People often will say pi is about 3.14159, and sometimes they'll take the decimal further. But the fact is, pi cannot be written as a fraction. Other common examples are things like the square root of 2, the square root of 3, the square root of 5, square root of 6, square root of 7, square root of 8, and the square root of 10, and so on. Hopefully you notice I did skip over a couple square roots. I skipped over the square root of 4 and the square root of 9. The square root of 4, on the other hand, since the square root of 4 equals 2, the square root of 4 actually is a natural number, as is the square root of 9. So it's not that all square roots are irrational, just many of them are. The other thing to be aware of with irrational numbers is when you're dealing with decimals. If a decimal repeats, it is rational. If a decimal terminates, it is rational. So the only decimals that are left would be numbers like 0.13113, 1113, 11113, where they are decimals that do not repeat and they do not terminate. Now this example of 0.13113, 1113, 11113 has a pattern to it, but not every irrational number has a pattern in its decimal. The key when looking at a decimal and deciding is it irrational or rational, if it repeats or terminates, it is rational. If it doesn't repeat and it doesn't terminate, then it is irrational. The one other thing to add into the mix is some of these sets do have special symbols used to represent them. The set of natural numbers is often represented by the symbol, what I call a double bar n. This n stands for the n in natural numbers. Integers has a special symbol as well. It's represented by a double bar z. And rational numbers are represented by the symbol, a q with a bar on the left side. Q standing for quotient, which is another way to say fraction. If you take all the irrational numbers and rational numbers, which rationals therefore include integers, whole numbers, and natural numbers, you obtain the set of real numbers. And the set of real numbers is represented by the symbol, the double bar r. These are all the numbers that you can find or place on a number line, and they are the numbers that we will focus on this term. Future math courses will predominantly rely on the real numbers, but there are many times, depending how far you go with your mathematics, that you may work with a larger number system.